Tonight, we are going somewhere more alien than the surface of Mars and far older than the modern continents. This realm exists right now on our shared world, yet its inner workings remain almost entirely hidden from human eyes. We speak of Antarctica. This is not merely a journey into a land of polar snow and sub-zero gales. It is a journey into a locked planetary vault, an ancient planetary memory, and a hidden kingdom operating under completely different physical laws. Beneath this vast white blanket lie active volcanoes churning in pitch darkness, subglacial lakes sealed away for 15 million years, rivers running uphill, hidden mountain ranges matching the European Alps, and the ultimate scar of an extinction event that changed the history of life forever. What lies hidden beneath the world's thickest coat of ice? If this kind of slow, quiet exploration is something you enjoy, I would be grateful if you would leave a like and subscribe to Midnight Sleep Documentary. And if you would tell me in the comments where you are listening from and what time it is where you are, that is always a quiet comfort to read. Now settle in, dim the lights, let your breathing slow. We are leaving the map behind. When we consider the frozen crown at the bottom of our world, we tend to picture a thin, static sheet of frost stretched over flat rock. We assume that Antarctica is simply a solid, lifeless desert where nothing changes and time stands completely still. But that common assumption, like our surface maps, is entirely wrong. In reality, Antarctica is the highest, driest, coldest, and windiest landmass on Earth. It is an ocean of water disguised as a hyper-arid desert. The ice here is not a mere surface coating, but a massive geological force weighing down upon the planet. On average, this continental cap measures over 2 kilometers in thickness, while in its deepest subglacial trenches, the frozen layer plunges down to nearly 5 kilometers deep. To put that into perspective, 5 kilometers of solid ice exceeds the total altitude of almost every major mountain peak found across other continents. This colossal weight accumulated over 34 million years of relentless snowfall, layer after layer, compressing under its own immense gravity. It is so incomprehensibly heavy that it has physically crushed the continental crust deep into the Earth's mantle. The land lies depressed by hundreds of meters below its natural equilibrium through a phenomenon known as isostatic depression. If every trace of this frozen blanket were to vanish instantaneously tonight, the bedrock beneath would spring back upward toward the sky, though that geological rebound would take 10,000 years to fully complete. The continent is literally bowing in absolute submission to the immense ocean of frozen water resting upon its back. Yet, this ice is not just heavy, it is an irreplaceable library of deep time. The atmosphere trapped inside its lowest layers contains fossilized air from forgotten epochs. The dust suspended within its crystalline strata holds the microscopic ash of primordial volcanic explosions and ancient asteroid strikes. To walk upon the high Antarctic plateau is to tread upon the physical pages of planetary history. We feel as though we are standing on an unyielding, immovable foundation. But as we look closer, we realize this ice is far from stationary. It behaves like a slow, crushing fluid that flows, fractures, and sometimes releases monsters into the dark. We often imagine the Antarctic landscape as an eternal monument, locked firmly in place until the end of time. But the idea that this frozen wilderness is forever dormant is a complete illusion. To grasp how dynamic this continent truly is, we must look at a single floating titan known to science as A23A. It is currently recognized as the largest iceberg on Earth, a monstrous block of consolidated snow and ice weighing nearly 1 trillion tons. Its surface spans approximately 4,000 square kilometers, making its footprint larger than the state of Rhode Island and double the total area of Greater London. For decades, this sleeping leviathan remained completely motioned. It originally tore free from the Filchner-Ronne ice shelf back in 1986 during the final years of the Cold War, but it was unable to escape into the open ocean. Its immense keel, a deep underwater mountain of solid ice extending hundreds of meters beneath the waves, plowed directly into the shallow ocean floor. It grounded itself firmly into the sediment. For more than 30 years, it sat anchored as a stationary island of ice while human history passed it by. Then, in the year 2020, its long sleep came to an end. The surrounding seawater warmed ever so slightly, or perhaps the seafloor beneath its massive weight finally eroded away. A23A lifted off the ocean bed. It began to float. Today, this trillion-ton ghost is drifting slowly northward, steered by powerful polar currents toward the ocean waters surrounding the South Orkney Islands. It is a slow-motion giant, marching toward its ultimate destruction in warmer northern latitudes. It serves as a stark reminder that nothing here is permanent. The solid ground beneath your feet today may become the open sea you sail through tomorrow. The absolute physical presence of this ice mass creates an environment that defies standard human intuition. We are looking at a layer of solid water that reaches depths greater than 4 kilometers in multiple basins. This is not just an outdoor landscape, it is a pressurized vault that seals the land away from the atmosphere, the sun, and the steady progression of surface seasons. Under such immense gravitational weight, basic physical laws begin to warp. The pressure generated at the bottom of the ice sheet is so extreme that it significantly depresses the freezing point of water. This creates an extraordinary natural paradox. While the surface of the polar plateau experiences temperatures that rank among the coldest in the known universe, the deep underbelly, where the ice meets solid rock, is wet. The intense pressure from above melts the base of the glacier from below, generating a vast, hidden lubrication network. The entire Antarctic ice sheet does not rest on dry, solid stone. It floats on a continuous, microscopic film of liquid water. This slick layer acts as a greasy slide, allowing millions of cubic kilometers of ice to creep down from the continental interior and glide into the ocean. It is a shifting, dynamic lid concealing an entire continent, a heavy white blanket capable of twisting the Earth's crust out of shape. But to understand why this vast repository of ice has endured for tens of millions of years, we must look beyond the land and turn toward the wild, churning ocean that encircles it. We often picture continents as land masses shielded by massive granite barriers, towering shoreline cliffs, or familiar borders drawn in stone. We naturally imagine that Antarctica remains frozen, simply because of its remote placement at the absolute base of our globe, isolated at the bottom of standard map projections. Yet that geographic explanation falls entirely short of reality. This southern domain is protected not by walls of stone, but by a wild, infinite moat of ocean water. Surrounding the frozen continent is the Antarctic Circumpolar Current, the largest and most powerful ocean current on planet Earth. It forms a continuous, churning river of sub-zero ocean water that flows endlessly from west to east, sweeping around the entire globe without ever crashing into a single piece of land. Every second of every day, this colossal current moves an astonishing 130 million cubic meters of water. It operates as an impenetrable thermal barrier. It builds a liquid wall that blocks the warmer oceanic flows of the Pacific Ocean, the Atlantic Ocean, and the Indian Ocean from ever drifting southward toward the pole. For 34 million consecutive years, this current has locked Antarctica inside a thermal prison, completely isolating its environment from the climate rhythms of the surrounding planet. It is a biological and atmospheric cage made of cold water. Within this closed loop, the polar weather operates entirely under its own uncompromising laws, preserving the vast continental ice sheets, guarding the deep polar stillness, and sealing the land's subterranean secrets away from a warming world outside. This churning current is the direct, singular cause behind the death of the ancient polar forests, and it is the true reason the Grand White Silence originally began tens of millions of years ago. If we were able to strip away this continuous cap of ice, to lift the frozen roof off the continent entirely, we would not find a flat, eroded plain scraped smooth by time. Instead, we would stand before a wild, jagged, and soaring mountain wilderness, buried in total darkness. Deep within the central region of East Antarctica, buried beneath the very thickest section of the continental ice sheet, sits a colossal range of mountains that seems to defy geological sense. These are the Gamburtsev Mountains. They are phantom peaks. Not a single human eye has ever gazed upon their cliffs, and no polar breeze has brushed their stone summits for 30 million years. They were first detected not by foot expeditions crossing the snow, but by Russian researchers during the 1950s who deployed seismic sounding instruments across the endless polar interior, listening carefully to the faint acoustic echoes bouncing off the deep bedrock below. The subterranean map that emerged from those echoes was astounding. This is no modest system of rolling hills. It is a colossal mountain chain, comparable in length, scale, and height to the European Alps. Its highest peaks soar up to 3,000 meters toward the sky, tearing directly into the soft underbelly of the overlying ice sheet. The soundings revealed razor-sharp ridges, sheer vertical cliffs, and deep, U-shaped valleys, originally carved out by ancient, warm-water rivers. The ultimate mystery lies in their unnatural survival. Normally, moving glacial ice acts like coarse sandpaper, grinding granite down into flat stumps over millions of years of movement. Here, however, the ice sheet performed the exact opposite function. It acted as an eternal preservative, freezing the entire alpine landscape in time and protecting its dramatic contours from erosion like an insect trapped in golden amber. They remain a pristine, fossilized mountain system, standing in total, pitch-black darkness, bearing the crushing load of an entire continent upon their granite shoulders. Yet beneath the immense mass of this ice lie structures far more unsettling than hidden alpine peaks. In the desolate quadrant known as Wilkes Land, locked deep under kilometers of solid glacier, satellite instruments picked up a strange anomaly resting in the bedrock. Scientists did not discover this subterranean feature using optical light or surface photography. They detected it through subtle variations in planet Earth's gravitational pull. Deep within the continental crust sits a mascon, a massive concentration of dense matter that pulls noticeably on satellites as they orbit high above the atmosphere. This gravitational footprint is immense, delineating a gargantuan circular structure nearly 300 miles or 500 kilometers in diameter. This is the Wilkes Land anomaly. The prevailing scientific theory suggests that we are looking at an impact crater, though not an ordinary one. If this geological interpretation holds true, it represents the scar of a cosmic collision 2 to 3 times larger than the famous asteroid strike that wiped out the dinosaurs. It rests in the deep bedrock, a silent, circular scar completely flooded and hidden by kilometers of solid ice. To grasp the sheer scale of this ancient cataclysm, we must realize that the space rock responsible for this crater may have measured approximately 30 meters across. Its arrival would have rung our planet like a massive bronze bell, sending hypervelocity shockwaves tearing through the crust with enough violence to shatter the rock on the exact opposite side of the globe. The estimated age of this hidden crater brings us face to face with a terrifying moment in cosmic history. Radioactive dating of surrounding rock formations points back to roughly 250 million years ago. That specific number sends a chill through every geologist who hears it, for it matches the date of the Great Dying, the devastating end Permian extinction event we spoke of earlier. During that brief, catastrophic window, 96% of all marine and terrestrial life on Earth vanished from existence. For decades, researchers attributed this global die-off solely to the massive volcanic eruptions of the Siberian Traps. But the Wilkes Land crater introduces a far more complex and terrifying possibility. Could this cosmic impact have served as the initial trigger? An asteroid striking Antarctica with such titanic force could have punched through the Earth's upper crust, violently agitating the underlying mantle and forcing superheated magma to erupt through the crust on the exact opposite side of the planet. It is entirely possible that Antarctica conceals the smoking gun for the most lethal catastrophe in the history of planetary life. The evidence remains locked beneath the coldest blanket on Earth, waiting for us to drill through the miles of ice and touch the stone that ended the old world. So how did we first come to realize that beneath all this solid, frozen weight lay vast bodies of liquid water? We naturally assume that beneath kilometers of polar ice, the world is entirely dry and frozen solid. We imagine a monolithic block of ice fused directly to frozen rock, locked in place by sub-zero cold. But that long-standing scientific picture, like so many early maps of the far south, turned out to be a quiet misunderstanding. The realization that liquid water exists deep beneath the Antarctic ice sheet did not arrive overnight. It began as a strange ghost signal appearing in seismic data at the absolute height of the Cold War. In 1964, Soviet researchers, dragging heavy seismic measuring equipment across the vast, white wastes near the Pole of Cold, noticed something deeply puzzling in their acoustic readings. Normally, sound waves fired down through the glacier bounce back in jagged, irregular patterns, echoing off the rough, scarred topography of the buried bedrock. But over one massive, specific region, the signal returned completely flat, perfectly, impossibly smooth. For years, scientists dismissed this reading as an instrument error, a simple glitch in the data. It was not until 1973 that the mystery was finally solved, when joint airborne radar surveys conducted by British, American, and Danish research teams flew across the interior. Their ice-penetrating radar beamed signals deep through the frozen cap and bounced off a subterranean boundary that returned a reflection as crisp and clear as a glass mirror. It was the unequivocal signature of liquid water. Resting beneath 4 full kilometers of solid ice lay a massive, unfrozen liquid horizon. Not a small pocket of damp soil, but a colossal subterranean ocean hidden in the dark. We tend to imagine subglacial water as mere trickle lines, damp mud, or minor meltwater puddles trapped in stone cracks. Yet the reality waiting down in the deep basin shatters that modest imagery entirely. This vast subterranean water mass is Lake Vostok, the undisputed crown jewel of the Antarctic underworld. To comprehend its colossal proportions, we might picture Lake Ontario in North America, but covered by an unbroken ceiling of glacial ice 2.5 miles thick. It stretches across an astonishing 149 miles in length and spans 31 miles in width. This body of water has remained hermetically sealed away from the surface atmosphere and the sun for at least 15 million years. It is, without question, the most isolated and lonely body of water on planet Earth. Down inside this subterranean abyss, perpetual and absolute darkness reigns. The pressure exerted upon the lake's upper surface exceeds 350 atmospheres, a crushing force capable of flattening a heavy nuclear submarine like a discarded aluminum soda can. Yet, despite these brutal parameters, the water remains entirely liquid. It is kept from turning to ice by the vast weight pressing down from above, combined with the soft geothermal warmth radiating continuously from the Earth's molten core below. This creates a natural thermal blanket effect. The massive glacier overhead functions as a perfect thermal insulator, trapping the planet's interior fire against the liquid basin and keeping the water temperature hovering just above the freezing point in a delicate, eternal equilibrium. We might think that such a locked, pressurized, dark reservoir would be chemically inert and utterly devoid of life. But that assumption fails to account for the strange, relentless chemistry generated by millions of years of isolation. As the continental glacier slowly glides across the top of Lake Vostok, its lowest ice layers melt under the immense pressure, steadily introducing new water into the lake system. Entrapped within that ancient ice are tiny air bubbles, samples of Earth's atmosphere locked away millions of years in the past. When the bottom ice thaws, those compressed air pockets are liberated into the liquid realm. Because the lake is trapped beneath a mountain of ice under high pressure, the liberated gases have nowhere to escape, forcing them to dissolve directly into the water. Over millions of years of continuous melting, this mechanism has pumped the lake full of concentrated gas. Researchers calculate that Lake Vostok's water is supersaturated with oxygen, containing up to 50 times more dissolved oxygen than a standard freshwater lake on the surface. While oxygen is essential for biological life in normal environments, at these extreme concentrations it transforms into a highly toxic, corrosive chemical agent. Lake Vostok is not merely cold and dark, it is a hyper-oxygenated chemical pressure cooker. Any organism dwelling in its depths must possess extraordinary biological adaptations to survive conditions that would instantly poison a normal freshwater fish or crab. Yet life possesses an astonishing, persistent tenacity. When international teams drilled boreholes down toward the hidden lake, stopping just short of breaching the liquid surface to prevent chemical contamination, they extracted cores of accretion ice, water from the lake that had frozen onto the underside of the sliding glacier. Inside these ice samples, geneticists discovered active DNA signatures. They identified extremophile bacteria capable of thriving in sub-zero darkness. Among these were thermophilic microbes, suggesting that hot hydrothermal vents spew mineral-rich water onto the lake floor, sustaining ecosystems through chemosynthesis rather than solar radiation. Even more surprising were DNA fragments indicating multicellular complexity, fungi, crustaceans, and even a genetic sequence resembling a parasite typically hosted by fish. This sparked a controversial theory among astrobiologists. Could blind, white shoals of fish be swimming through the pitch-black abyss of Vostok, completely sheltered from the ice ages that reshaped the world above? For now, the lake remains unbreached, a sealed biological vault waiting for future exploration. So what does this isolated ocean of water locked under kilometers of polar ice tell us about the possibility of life on distant, frozen moons floating across our solar system? Our relentless, quiet fixation on the dark depths of Lake Vostok is driven by something far grander than simply unraveling the terrestrial history of our own planet. It serves as a vital, irreplaceable rehearsal ground for deep space astrobiology and the search for extraterrestrial life. When we direct our optical telescopes and remote probes toward the outer reaches of our solar system, we gaze upon distant, ice-crusted moons, such as Jupiter's frozen Europa and Saturn's gleaming Enceladus. These celestial bodies are essentially planetary shells of solid ice, harboring global saltwater oceans beneath miles of frozen exterior crust, sustained through time by tidal friction and deep internal geothermal activity. In their fundamental structure, mechanics, and chemistry, they closely resemble Lake Vostok on a planetary scale. If living organisms can adapt, persist, and flourish within the pitch-black, hyper-pressurized, oxygen-dense waters of Vostok, completely cut off from sunlight and the surface atmosphere for tens of millions of years, then biological systems can surely exist within the hidden, dark abysses of Europa or Enceladus. Lake Vostok functions as our terrestrial proxy, It provides the closest physical and chemical analog to an extraterrestrial ocean available anywhere on Earth, proving that every piece of data extracted from Antarctica's subglacial depths brings us one step closer to answering whether we are truly alone in the vast cosmic dark. The ice of the far south operates as a quiet telescope looking directly into the biological possibilities of the cosmos. Yet Antarctica remains a land defined by intense, dramatic physical paradoxes, none more visually striking or violent than the towering structure of Mount Erebus. Situated on Ross Island, rising nearly 4 full kilometers directly out of the frozen sea, this massive giant stands as the southernmost active volcano on planet Earth. It serves as a solitary sentinel of volcanic fire, standing perpetual guard over an endless kingdom of ice. Mount Erebus has remained in a state of continuous eruption for at least 1.3 million years, operating not as a dormant geologic relic, but as an active, breathing thermodynamic engine. At its lofty summit crater lies an extremely rare geological phenomenon, found in only a tiny handful of locations across the globe: a permanent, violently churning lake of open molten lava. The visual contrast generated by this mountain is utterly surreal. Against a blinding, endless expanse of white ice sheets and the deep sapphire hue of the polar sky, a continuous plume of volcanic steam and sulfurous gas drifts steadily from the summit crater. During the long, dark months of unrelenting polar winter, when the sun disappears entirely, the summit glows with a menacing red light, illuminating the undersides of passing cloud decks and sulfur plumes. It stands as an open portal into the Earth's molten interior. Here, a boiling cauldron of phonolite lava, a rare, mineral-rich type of molten rock laden with alkali metals and feldspar, bubbles continuously at temperatures exceeding 1,000 degrees Celsius, directly framed by glacial ice frozen solid at -50 degrees Celsius. It is a brutal thermal battleground where the planet's internal heat collides directly with its most unforgiving external cold. However, the true physical wonder of Mount Erebus is not found at its glowing summit crater, but hidden lower down along its vast, frozen flanks. The geothermal heat escaping from the interior of the volcano does not merely vent into the polar atmosphere. It seeps through porous rock fractures and encounters the thick glacial overlay covering the mountain. This delicate interaction carves out ethereal, ghost-like hollow structures known as fumarolic ice chimneys, towers of frozen condensation standing up to 10 meters tall, continuously venting volcanic steam into the frigid polar air. Directly beneath these hollow ice chimneys, the escaping geothermal heat has carved out an extensive, secret network of ice caves directly into the body of the glacier itself. To step into these ice caverns is to enter a fantasy landscape hidden beneath the snow. The cavern walls are composed of translucent blue glacial ice that glows faintly with filtered sunlight trickling down from the surface. The cavern floors consist of warm, volcanic bedrock and soft, dark volcanic sand. The air inside remains thick, humid, and misty, completely shielded from the violent katabatic winds raging across the open glacier just a few meters above. It is a hidden sanctuary carved entirely by the warm breath of the volcano within solid ice. The temperature difference between the interior of these caves and the outside world is staggering. Outside, on the exposed slopes of the mountain, the bitter sub-zero wind chill can freeze exposed human skin in mere minutes. Yet inside these thermal chambers, deep within the ice, the temperature can reach a balmy 25 degrees Celsius. It is t-shirt weather cradled within the coldest continent on Earth. Standing in this warm, humid darkness, listening to the quiet drip of melting ice and the soft hiss of escaping steam, you lose all physical sense of polar geography, surrounded not by an icebox, but by a subterranean sauna. This subterranean thermal stability creates a stable biological sanctuary that has quietly endured for hundreds of thousands of years, completely isolated from the harsh polar climate outside. Life, as we know, inherently abhors a vacuum, taking hold wherever warmth and liquid water intersect. So what silent forms of life have taken root within these warm, blue-lit caverns beneath the volcano? When researchers ventured into the steaming ice caverns of Mount Erebus to extract biological samples, they expected to find simple surface microbes carried in by high-altitude polar winds. But the biological reality discovered inside these volcanic chambers shattered that conservative assumption. Analyses of the genetic material retrieved from the damp soil and warm ice walls revealed traces of mosses, microscopic algae, and small invertebrate organisms flourishing in the balmy, moist darkness. Yet the most intriguing aspect of the DNA sequencing was what it failed to match. Multiple genetic strands recovered from the subterranean soil did not correspond to any known species recorded in global biological databases. This intriguing discrepancy strongly suggests that the ice caves of Erebus harbor a unique, fully isolated subterranean ecosystem. These plants and tiny creatures have spent countless generations evolving in total isolation, adapting specifically to a world defined by volcanic steam, geothermal heat, and dim, blue-filtered ice light. It raises the tantalizing possibility that complex life forms exist deep within Antarctica that have never once gazed upon the polar sky, specialized creatures residing inside a hollow, geothermal mountain. While Mount Erebus stands as a visible, smoking giant on the horizon, it is likely just a single exhaust stack for a vastly larger subterranean volcanic engine. We naturally picture West Antarctica as an ancient, geologically dead basement of granite, locked under thousands of meters of ice. But that assumption of tectonic dormancy is fundamentally flawed. In 2017, scientists analyzing high-resolution ice-penetrating radar maps of West Antarctica uncovered a startling tectonic reality. Buried 2 kilometers beneath the solid surface ice, hidden entirely from view, they identified the distinct conical shapes of 91 previously unknown volcanoes. This extraordinary finding established the West Antarctic Rift System as one of the densest and largest volcanic provinces on Earth, directly rivaling the immense Great Rift Valley of East Africa. Most of these subglacial peaks are currently dormant, crushed into temporary silence by the immense weight of the overlying ice sheet. But dormant volcanoes are not dead. If these subglacial peaks were to reawaken, the global environmental consequences would be staggering. A major eruption beneath the glacier would not necessarily breach the surface or blast ash into the polar sky. Instead, the massive thermal output would melt the base of the ice sheet from below, creating vast, pressurized subglacial lakes that act as extreme lubricants between the bedrock and the ice. This super-slick layer would unstick the massive glaciers, allowing them to slide exponentially faster into the surrounding ocean. The geothermal fire below serves as an unpredictable wildcard, capable of destabilizing the entire West Antarctic ice sheet from the bottom up. The continental ice is not merely thawing from warm air above. It rests upon a giant geological stove that may be slowly turning on. Yet, the ice sheet is far more than a physical weight or a melting lid covering volcanic rifts. It is a physical recording device, an immense, pristine repository of planet Earth's atmospheric history. As fresh snow falls upon the high Antarctic plateau, the sub-zero temperatures ensure it never thaws. Year after year, century after century, snowfall accumulates in endless, delicate layers. As the increasing weight of newly fallen snow presses down on the older layers beneath, it compresses the crystalline structure into solid glacial ice, trapping tiny pockets of atmospheric air between the crystals. When the snow fully consolidates into dense ice, these air bubbles are hermetically sealed forever. They become microscopic time capsules, direct, pristine samples of Earth's atmosphere from the precise year and century they were buried. By drilling deep into the interior ice sheet and extracting long cylinders of ice over 3 kilometers deep, scientists obtain a continuous vertical timeline of planetary history. When these ice cores are brought to the surface and melted inside a sealed vacuum chamber, the ancient air bubbles pop and hiss as they are released. It is the literal sound of the past exhaling. Researchers can breathe the exact air inhaled during the Roman Empire, measure volcanic dust from pre-human eruptions that darkened ancient skies, and calculate exact greenhouse gas concentrations from past ice ages. The famous Vostok ice cores have provided a high-resolution logbook of planetary climate stretching back 800,000 years, documenting every thermal shift the planet has endured. What happens then when this ancient ice matrix encounters the deep rock below, producing features that seem to defy the very nature of cold? At the snout of the Taylor Glacier within the McMurdo Dry Valleys, we encounter a site that resembles a deep, open wound in the side of the world. Standing out against the blinding white expanse of the ice and the muted grey of the bare rock, a visceral, deep crimson liquid steadily pours directly out of the glacier's frozen snout. It stains the ice red as it cascades downward into the frozen basin of Lake Bonny below. This dramatic geological feature is known as blood falls. For decades, early explorers believed the intense red coloration was caused by dense blooms of red algae trapped within the ice. But the chemical truth behind this stream is far stranger. The liquid pouring out is not water mixed with organic pigments, it is liquid rust. The stream originates from a subglacial lake trapped deep beneath the heavy glacier for over 1 million years. This ancient reservoir consists of hypersaline water, a dense brine 3 times saltier than the open ocean, which lowers its freezing point and allows it to remain liquid even at temperatures of -10 degrees Celsius. It is also saturated with iron scraped from the bedrock by the relentless grinding of the glacier above. When this iron-rich, oxygen-deprived brine reaches the glacier's face and touches the atmosphere for the first time in an eon, it oxidizes instantly, turning a deep crimson red. The glacier is physically bleeding iron oxide. Yet, this salty brine carries more than mineral oxides. It harbors an ecosystem of unique bacteria. These microbes have survived in total darkness for over 1 million years, breathing iron and sulfur instead of oxygen. Blood falls serves as a colorful, dramatic signal flare, pointing toward the hidden, microscopic life thriving in the dark subglacial underworld. Beyond preserved terrestrial ecosystems, Antarctica acts as planet Earth's primary collection net for extraterrestrial artifacts. Space debris and meteorites fall across our planet at a steady, uniform rate, but in dense forests or open oceans, these space rocks are lost forever. In Antarctica, however, dark meteorites land upon a vast, uniform sheet of white snow, making them remarkably easy to spot. But the continental ice does far more than provide high-contrast visual backdrops. It physically gathers the space rocks together. As the massive ice sheets creep slowly from the high interior plateau toward the coastline, they carry embedded meteorites along with them. When the moving glacier strikes a buried mountain range, its forward motion slows, and its upper layers are gradually ablated away by fierce, dry polar winds. As the surface ice evaporates into the dry air, ancient meteorites trapped deep within the frozen layers are left behind on the surface, accumulating over centuries into concentrated stranding fields. Researchers can walk across these blue ice fields and pick up extraterrestrial rocks that originated in the distant asteroid belt, on the Moon, or even on the surface of Mars. Some of the most significant Martian meteorites ever recovered, including specimens containing chemical signatures that sparked debates over ancient microbial life on Mars, were gathered directly off the Antarctic ice. It remains a striking cosmic paradox that the absolute best place on Earth to study the geology of our solar system is by looking down at the frozen ice of the South Pole. Standing on the barren, wind-scoured polar plateau today, it is difficult to imagine that this frozen landscape was once loud with the sounds of a bustling green wilderness. But if we were to travel backward in time 100 million years to the Cretaceous period, the silent polar wastes would disappear, replaced by roaring waterfalls and the calls of prehistoric beasts. During that era, Antarctica was not a frozen continent. It stood as the central cornerstone of the southern supercontinent Gondwana. Physically connected to what we now know as Australia and South America, it formed part of a vast southern domain. Although the landmass sat further north than its current location, it still resided within the polar circle. Yet because the Cretaceous world experienced a super greenhouse climate, devoid of polar ice caps, Antarctica was lush, warm and thriving. The land was covered in expansive temperate rainforests, similar to those found in modern-day New Zealand or Patagonia. Winding rivers cut through fertile valleys that are now buried beneath miles of solid ice, and the air was thick with pollen and insect life. Antarctica was a green polar paradise at the bottom of the ancient map. The physical evidence of this forgotten green world remains perfectly preserved within the Antarctic bedrock. Along the Antarctic Peninsula and within the Transantarctic Mountains, paleontologists have unearthed fossil remains that completely shatter our standard perception of the polar regions. They have discovered fossilized leaves from ancient southern beech trees, Nothofagus, alongside the fronds of giant prehistoric ferns. But the most profound discoveries are the fossilized tree root systems preserved in situ, found embedded in the exact rock layers where they originally grew millions of years ago. This proves that these vast forests were not drifted here by ancient ocean currents. They grew directly on Antarctic soil. Yet living at the South Pole presented a unique environmental challenge, even in a warm world. Due to the tilt of Earth's axis, the polar region experienced months of continuous winter darkness, followed by months of non-stop summer daylight. These ancient polar forests had to adapt to a light cycle found nowhere else on Earth. The trees entered dormancy during the long winter nights, dropping their leaves to conserve energy, and then exploded into rapid growth during the 24-hour sunlight of the polar summer. It was a world of long shadows and unique biological rhythms, adapted to a light cycle that would seem alien to any modern tree. What final thermal surge did this green polar continent experience before it was locked away in the deep freeze? Before the Great Deep Freeze claimed the southern continent, planet Earth experienced one final, dramatic greenhouse spike known as the Paleocene-Eocene thermal maximum. Roughly 56 million years ago, atmospheric carbon dioxide levels soared to extreme heights, heating the global climate to temperatures unprecedented across the entire Cenozoic era. Along the low-lying Antarctic coastlines, palm trees, ancient macadamia-like flora, and lush, dew-drenched fern gardens flourished in mild, temperate to subtropical conditions. The ocean waters washing against the polar shores were as warm as the modern Mediterranean Sea, while swampy, humid wetlands stretched across vast inland valleys that are now buried under miles of solid, unforgiving glacial sheet. It was a golden, balmy twilight for the southern polar biosphere, an astonishing epoch where tropical-style rainforests stood resiliently under months of continuous polar summer sunshine. The atmosphere during this subtropical heatwave was thick with moisture and rich with early avian and insect life. Soil cores extracted from deep marine sediments reveal that winter temperatures along these polar margins rarely dropped below freezing, allowing delicate botanical species to survive continuously without facing severe frost damage. River systems wound through lush, green canopy forests, carrying warm runoff out into the surrounding polar seas. Yet, this vibrant, emerald world was ultimately living on borrowed time. The slow, unyielding dance of tectonic plates was already quietly preparing the stage for a catastrophic climate plunge that would permanently wipe the green world from the surface map, replacing palm fronds with endless fields of blue ice and blowing snow. As we fast forward through tens of millions of years of continental freeze, we arrive at the modern era, where the stability of this vast icy cap rests upon a critical, vulnerable linchpin. Floating on the edge of West Antarctica, pushing out into the wild expanse of the Amundsen Sea, sits a single, gargantuan sheet of ice known to modern glaciology as the Thwaites Glacier. Spanning roughly 192,000 square kilometers, Thwaites covers a geographic area roughly equivalent in size to Great Britain or the state of Florida. In modern polar science, Thwaites is universally recognized as a classic keystone feature, a geological anchor holding an entire regional system in place. The concept of a keystone glacier is simple in principle, yet staggering in its global implications. Thwaites acts as a giant natural dam, physically blocking and buttressing a vast portion of the West Antarctic ice sheet like a massive, structural stone arch. The glacier rests upon a deep seabed basin, serving as the outer plug that prevents interior glaciers from freely sliding downhill into the ocean. If Thwaites were to suffer a complete structural collapse and disintegrate, it would not merely spill its own immense volume into the surrounding sea, it would pull down the surrounding tributary glaciers along with it, unspooling the entire ice sheet sitting behind its icy walls. Glaciologists estimate that the full collapse of Thwaites and its neighboring ice catchments contains enough frozen water to raise global sea levels by as much as 3 full meters, permanently flooding low-lying islands, altering world ocean dynamics, and reshaping every coastline and major port city on planet Earth. It stands, in the most literal geological sense, as the structural cornerstone holding up the western half of the frozen continent. For decades, polar researchers and satellite missions monitored Thwaites primarily from above, tracking surface crevasses, ice velocity vector lines, and elevation profiles. But the true existential threat to the integrity of this keystone glacier was not taking place in the open air. It was occurring in absolute, pitch-black darkness, deep beneath the ocean surface. In recent years, oceanographic probes, specialized ice drilling teams, and autonomous underwater vehicles deployed deep beneath the floating ice shelf of Thwaites revealed a deeply concerning thermal dynamic. Deep ocean currents are actively transporting streams of circumpolar deep water, warm, salty ocean currents originating from lower latitudes that sit well above the freezing point of ice, directly into the deep sub-ice cavities beneath the glacier. This warm water is not attacking the visible icy cliffs towering above the sea surface. It is attacking the vulnerable underbelly where the glacier rests upon the marine bedrock, a critical boundary known to scientists as the grounding line. Because the bedrock beneath West Antarctica slopes backward and downward toward the interior center of the continent, the grounding line of Thwaites sits inside a deep, reverse-sloping trough far below sea level. As these dense, warm ocean currents carve out massive hollow chambers, subterranean arches, and subglacial caverns along the underside of the ice shelf, the grounding line is forced to retreat further and further inland, unmooring the heavy ice mass from its ancient anchor points on the seafloor. The glacier is effectively being cooked, eroded, and dissolved from below, losing its structural grip on the bedrock, while its upper surface appears deceptively flat and intact to the naked eye. It is an unseen, subterranean melt mechanism operating away from human sight, accelerating the glacier's relentless march toward the open ocean and transforming what was once a solid, unyielding, icy shield into a floating, heavily fractured shelf on the verge of detachment. What happens when these hidden underwater caverns beneath the Keystone Glacier finally reach a point of complete structural failure? When the structural integrity of a coastal ice shelf degrades beyond repair, the physics governing the remaining glacier shift into a dangerous self-sustaining collapse mechanism. In glaciology, this critical threshold is defined through two twin mechanical concepts: marine ice sheet instability and marine ice cliff instability. To understand how a glacier as massive as Thwaites can unspool so rapidly, we must examine the physical geometry of the ground beneath it. Because the bedrock of West Antarctica slopes downward as one moves inland, the glacier becomes progressively thicker deeper into the continent. Under marine ice sheet instability, as warm ocean currents melt the grounding line back into deeper water, the exposed ice face becomes taller and heavier. Thicker ice naturally flows much faster into the sea under the pull of gravity, which accelerates the discharge, melting more ice and driving the grounding line even deeper into the subsea basin. This mechanical retreat triggers an even more formidable process along the open-air boundary. When an ice shelf disintegrates entirely, it leaves behind vertical walls of ice standing directly in the ocean. Physical laws dictate that solid ice cannot support a sheer vertical cliff higher than roughly 90 to 100 meters above the sea surface without crumbling under its own crushing weight. Under marine ice cliff instability, once an ice wall reaches this critical height, the sheer compressive stress exceeds the internal structural strength of the ice. The cliff face shears apart, collapsing into the ocean in massive, rapid carving events. Each collapse exposes an even taller cliff face behind it, generating a continuous, catastrophic chain reaction. The glacier effectively eats itself backward, transforming a solid, ancient ice sheet into a chaotic swarm of floating icebergs in a matter of decades. Yet while deep marine currents operate silently underwater, the atmospheric realm above the ice sheet generates its own fierce, planetary-scale force. High upon the central Antarctic plateau, sitting thousands of meters above sea level, the air experiences extreme thermal cooling. During the long months of total polar darkness, heat radiates out into space, leaving the air directly above the surface ice intensely cold, compressed, and dense. Because cold air is significantly heavier than the surrounding atmosphere, gravity begins to pull this massive pool of dense air downward toward the continental margins. This downward gravity-driven flow forms katabatic winds, the most powerful and persistent wind systems anywhere on Earth. As this supercooled air spills off the high interior plateau, it accelerates down the steep glacial slopes, gathering velocity as it surges toward the coast. These winds can easily reach sustained speeds exceeding 200 kilometers per hour, scouring the snow cover off the blue ice and driving bitter gales out onto the open ocean. When these fierce katabatic winds blast off the coast, they act as massive atmospheric brooms, physically shoving newly formed sea ice away from the shoreline and out into the open sea. This process creates open patches of water along the coast surrounded by sea ice, known as polinias. In these exposed coastal gaps, the frigid polar air comes into direct contact with open seawater, causing the water to freeze almost instantaneously. As quickly as new ice forms on the surface, the relentless winds blow it offshore, turning the polinias into continuous, natural sea ice factories. The creation of vast quantities of sea ice within these coastal polinias sets in motion a global hydrological mechanism that affects every ocean on Earth. When seawater freezes into ice, its crystalline structure cannot accommodate dissolved mineral salts. Through a process known as brine rejection, the salt is squeezed out of the newly forming ice and expelled into the cold liquid water directly below. This rejected salt transforms the surrounding water into a hypersaline, ultra-dense liquid chilled to near its freezing point of -1.9 degrees Celsius. Because this brine-laden water is extraordinarily heavy, it sinks rapidly off the shallow continental shelf, cascading down the steep underwater slopes of Antarctica like a massive subterranean waterfall plunging into the dark abyss. This plunging flow creates Antarctic bottom water, the coldest, densest, and most saline body of water on planet Earth. Once Antarctic bottom water reaches the ocean floor, it spreads northward across the abyssal plains, traveling thousands of miles across the globe. It forms the deep foundational layer of the global ocean, creeping beneath the Atlantic, Indian, and Pacific Oceans, reaching all the way into the northern hemisphere. This deepwater movement drives the global thermohaline conveyor belt, the planetary circulation system that regulates global climate, redistributes heat, and carries dissolved oxygen from the polar atmosphere down into the deep ocean trenches. The frozen continent acts as the primary cooling engine and cardiovascular heart of the global ocean, pumping cold, oxygen-dense water through the deep veins of the Earth. If massive volumes of fresh meltwater from collapsing ice sheets dilute this coastal brine, the water loses its extreme density and can no longer plunge to the seafloor, threatening to slow the fundamental circulatory rhythm of the ocean. What happens to the global climate when the rhythmic beat of this oceanic circulatory pump begins to falter, and how did early human explorers attempt to map this unyielding, freezing wilderness? Long before satellite imagery, ice-penetrating radar, and thermal probes transformed Antarctica into an open laboratory, this vast southern domain existed as a blank, white expanse at the bottom of early maps. For centuries, cartographers designated the unknown region as Terra Australis Incognita, an imaginary warm landmass placed in the south to balance the heavy continents of the northern hemisphere. When human navigators finally pierced the icy ring of the Southern Ocean in the early 20th century, they stepped directly into an environment that tested the absolute outer limits of human biological and psychological survival. This period, known as the heroic age of Antarctic exploration, saw small groups of men venturing into an uncharted world armed with wooden ships, wool clothes, and leather boots. In December 1911, Norwegian explorer Roald Amundsen and his team successfully reached the South Pole by utilizing dog sleds, careful logistical planning, and a deep understanding of cold weather travel. Just 5 weeks later, British officer Robert Falcon Scott and his 4 companions stood at the exact same spot, only to find the Norwegian flag already fluttering in the sub-zero wind. Scott's party turned back to face an arduous 800-mile march toward their base camp, battling fierce blizzards, severe frostbite, and deep starvation. All 5 men perished in their tents, trapped by an unrelenting storm just 11 miles from a critical supply depot. Their journals, recovered months later, provided a quiet, moving record of human dignity, standing resiliently against an unyielding polar environment. Equally legendary was Sir Ernest Shackleton's 1914 Imperial Transantarctic Expedition. Shackleton's ship, the Endurance, it became trapped in the drifting ice pack of the Weddell Sea before ever touching the continental mainland. For 10 grueling months, the wooden vessel was slowly squeezed by the massive structural pressure of the pack ice until its heavy oak hull was crushed and splintered, sinking into 3,000 meters of icy water in late 1915. Shackleton and his crew lived on floating ice floes for over a year before navigating small, open wooden lifeboats across 800 miles of stormy, sub-zero seas to reach South Georgia Island, accomplishing one of the most remarkable rescue missions in maritime history. In 2022, deep-sea exploration teams deploying advanced submersibles located the wreck of the Endurance. Sitting on the seabed of the Weddell Sea, due to the total absence of wood-boring organisms in the sub-zero Antarctic waters, the ship was found in an astonishing state of preservation, its name still clearly visible across the stern, standing as a quiet, frozen monument to an extraordinary chapter of human history. The biological realities faced by these early polar explorers reveal much about the extreme thermodynamics of the far south. In temperatures dropping below -50 degrees Celsius, the human body transforms into an intense furnace, burning up to 6,000 to 8,000 calories per day simply to maintain internal core heat. In these frigid conditions, sweat becomes a deadly hazard. Moisture trapped within heavy clothing freezes into solid sheets of ice against the skin, conducting body heat away rapidly and accelerating hypothermia. Exposed skin freezes in seconds, while the unrelenting glare of sunlight reflecting off the high albedo snow causes severe snow blindness, burning the corneas of unprotected eyes. Added to these physical hardships was the profound psychological weight of the polar night, 4 continuous months of continuous darkness during winter, where human beings lived inside snow-buried huts, listening to the relentless scream of katabatic winds raging across a total void. While early explorers fought to survive on the frozen surface, the continent's outer edges were quietly generating some of the most massive structural features on planet Earth. Encircling much of the Antarctic coastline are ice shelves, gargantuan floating aprons of glacial ice attached to the continental mainland, fed by glaciers sliding down from the high interior. The largest of these structural features is the Ross Ice Shelf, a floating slab of solid ice covering an area roughly equivalent in size to the country of France or the state of Texas. It presents an imposing, continuous vertical ice wall rising up to 50 meters above the ocean's surface, extending hundreds of meters down into the dark water below. The Ross Ice Shelf, along with its eastern counterpart, the Filchner-Ronne Ice Shelf, acts as a massive structural break, stabilizing the inland glaciers and holding back the slow slide of the continental ice sheet. As these floating shelves creep steadily outward over the ocean, internal structural stresses, rising tides and ocean swells cause massive sections to crack and detach, giving birth to tabular icebergs. Unlike the jagged, irregular icebergs formed by mountain glaciers in the northern hemisphere, Antarctic tabular icebergs are colossal, flat-topped blocks of ice with sheer vertical cliffs and flat upper surfaces. Some of these floating giants span thousands of square kilometers, drifting through the Southern Ocean for years like autonomous, frozen islands. As these icebergs drift and slowly melt, they release a quiet, fascinating soundscape into the marine environment. Oceanographers deploying hydrophones underwater record deep, seismic groanings as the heavy ice flexes against ocean currents, accompanied by a continuous popping sound known to acoustic researchers as Bergy bit noise. This submarine crackle is produced by millions of tiny air bubbles, compressed under extreme pressure millions of years ago when the ice was formed, violently escaping as the ice matrix thaws. It is the literal acoustic release of ancient atmosphere, singing a quiet, microscopic song into the dark polar sea. Yet, despite holding nearly 70% of the planet's fresh water in the form of glacial ice, Antarctica harbors a region that seems to defy the very definition of a polar wilderness, a landscape where ice disappears entirely, revealing a dry, barren world of dark gravel and bare rock. Nestled within the Victoria Land region near McMurdo Sound lie the McMurdo Dry Valleys. Covering roughly 4,800 square kilometers, this network of ice-free valleys represents the largest ice-free region on the entire Antarctic continent. To step into the dry valleys is to leave the white blanket behind and enter an unearthly, hyper-arid desert. The region has received virtually no rain or snowfall for over 2 million years, making it the driest, most extreme desert environment on planet Earth. The total absence of ice in this region is driven by the fierce, continuous action of katabatic winds. As cold, heavy air descends off the polar plateau, it accelerates through the mountain passes, heating slightly as it compresses and dropping its relative humidity to near zero. These hyper-dry, gale-force winds blast through the valleys at speeds exceeding 200 kilometers per hour, instantly evaporating every flake of snow or drop of moisture before it can settle on the ground. The landscape of the dry valleys is shaped entirely by wind, cold, and time. Over millions of years, wind-blown sand grains have scoured the exposed granite and basalt boulders, carving them into strange, smooth, geometric rock sculptures known as ventifacts. Scattered across the gravel floors of these barren valleys are the mummified remains of crabeater seals and penguins that wandered inland from the coast thousands of years ago. Disoriented by snowstorms or dislodged from their colonies, these animals traveled miles into the dry interior, eventually succumbing to exhaustion and cold. In the hyper-arid, sterile air, their bodies did not decay. Instead, they were freeze-dried and perfectly preserved by the cold wind, their skin and skeletons resting undisturbed on the stone floors for millennia, looking as if they died only yesterday. Because of its extreme aridity, brutal cold, high radiation, and sterile soil, the McMurdo Dry Valleys serve as planet Earth's primary analog for the surface of Mars. Space agencies, including NASA, routinely deploy scientists and planetary rovers to these valleys to test life detection instruments and autonomous sampling drills before launching them on missions to the Red Planet. For decades, scientists believed the dry valleys were completely devoid of life. However, detailed microscopic analysis revealed that life had simply retreated inside the rock itself. Microscopic organisms known as endoliths, including specialized algae, fungi, and cyanobacteria, live inside the microscopic pores and tiny fissures of sandstone rocks. They survive by absorbing tiny droplets of condensation that form beneath the rock's surface, receiving just enough sunlight filtering through translucent quartz crystals to carry out low-level photosynthesis. They represent life reduced to its absolute, most resilient minimum, thriving in a cold, silent desert that mirrors the surface of another world. As we look toward the final chapter of our polar journey, how do these remote physical processes, ancient ice sheets, and hidden ecosystems connect to the future of our shared global climate? Long before modern satellite constellations mapped every square meter of the high polar plateau, human nations looked toward this silent southern continent with eyes of political ambition, territorial control, and untapped mineral interest. 7 sovereign nations made formal territorial claims over sweeping, pie-shaped wedges of the landmass, seeking long-term control over potential mineral wealth, marine access, and strategic footholds at the absolute bottom of the globe. Yet, as the geopolitical tensions of the Cold War deepened across the Northern Hemisphere, a remarkable and unprecedented moment of global diplomatic clarity emerged. In 1959, 12 nations came together in Washington to sign the historic Antarctic Treaty, establishing the entire continent as a peaceful international territory dedicated solely to open scientific inquiry, biological conservation, and diplomatic cooperation. The treaty strictly prohibits all military activity, weapons testing, nuclear waste disposal, and commercial mining operations, freezing all existing territorial claims in a state of permanent legal suspension. It remains one of the most resilient and successful international peace accords in human history, preserving an entire continent as a shared, peaceful sanctuary for global science and environmental stewardship. This peaceful legal framework enabled unprecedented scientific collaboration across national boundaries. Across decades of international research, scientists erected research stations across the high ice, sharing data, ice core samples, and geophysical measurements without the barrier of national borders. The continent transformed from a battleground of territorial ambition into a living laboratory where humanity works collectively to decode the fundamental mechanics of planet Earth. In an era frequently defined by geopolitical conflict and resource competition, Antarctica stands as a quiet testament to what human nations can achieve when they choose preservation over conquest. The treaty created a sanctuary where the quiet voice of natural discovery supersedes the noise of political expansion, ensuring that this pristine white wilderness remains unmarred by industrial footprint or military posturing. Within this international scientific sanctuary, modern researchers have come to realize that the frozen continent is far from a static, isolated block of ice sitting quietly at the bottom of the world. Instead, it functions as a highly dynamic, interconnected fluid system whose complex subglacial hydrology touches every corner of our shared global ocean. Deep beneath the miles of solid, suffocating ice lies a vast, hidden network of active rivers, streams, and over 400 subglacial lakes. These dark, pressurized bodies of liquid water do not remain trapped in isolated stone pockets forever. They slowly drain, overflow, and cascade into one another through dynamic subglacial channels, creating massive subterranean flood cycles that periodically lubricate the movement of the overlying ice sheets. This immense subglacial drainage system ultimately discharges its mineral-rich waters into the Southern Ocean, carrying vast quantities of dissolved iron and ancient nutrients into the marine environment. These subglacial plumes feed massive seasonal blooms of microscopic phytoplankton, which form the foundational base of the entire marine biological food web. From microscopic krill to giant blue whales, oceanic life thousands of miles away relies directly on the hidden chemical output draining out from beneath the Antarctic ice. What happens deep under the dark, pressurized ice directly dictates the biological productivity and carbon sequestration capacity of oceans across the globe. The subglacial hydrology acts as a continuous circulatory system, linking the dark interior bedrock to the sunlit surface waters of the world. Stepping back to observe Antarctica across tens of millions of years allows us to glimpse a profound, humbling deep-time perspective on our living planet. This continent is planet Earth's primary, irreplaceable vault of planetary memory, a pristine physical archive holding ancient trapped atmospheres, lost warm world ecosystems, cosmic meteorites, and structural records of devastating, catastrophic extinction events. Over its immense geological history, it has transformed from a warm, emerald paradise of subtropical palm trees, flowering plants, and temperate rainforests into a silent, frozen fortress of solid ice. This staggering transformation demonstrates the vast, unyielding, and radical climate shifts our planet is capable of undergoing when driven by orbital dynamics, atmospheric greenhouse gas variations, and tectonic drift. The colossal ice sheets resting upon this crushed continental crust are not permanent, unyielding fixtures of the Earth. They are dynamic, sensitive fluid structures that respond constantly to subtle changes in atmospheric and ocean thermodynamics. They hold the master key to future sea levels, ocean circulation patterns, and global climate stability. To study Antarctica is to understand the absolute fragility and interconnectedness of our global biosphere. The continent holds the frozen memory of where our world has been, while simultaneously serving as an early warning system for where our planet may be heading. As our long, quiet exploration through this silent, hidden realm comes to its final rest, we realize that Antarctica is far more than a cold, distant desert at the far edge of our maps. It is a living, breathing, and fundamental component of our planetary engine, guarding the ancient past while quietly shaping the future of our world. The vast white silence of the high polar plateau continues its steady, eternal rhythm, wrapped in the profound stillness of the dark polar winter nights and lit by the faint, shimmering glimmer of distant stars. The deep ice holds its ancient secrets in absolute quietude, waiting in the polar dark. Now, let the cold gales fade away entirely. Let your mind rest in the vast, peaceful stillness of the far south, and drift slowly into a deep, restful sleep. If you found this video useful, don't forget to like, subscribe, and turn on notifications so you never miss our latest updates. If you have a question, an experience to share, or a topic you'd like us to cover next, leave a comment below. We'd love to hear from you. Thanks for watching, and we'll see you in the next video.